everyone, welcome back to my channel Learning with Rachel. So first of all, don't forget to subscribe, like and share my channel. So today this video is about grade 6 changing circuits. Let's move on. So right over here, as you can see on your screens, an electricity can flow to the components in a complete electric circuit. So if you see in the first picture which is given, you see that the other side of the wire is not connected to the battery, so that's why the bulb is not glowing. And if you see in the second picture, the both sides of the wire is connected to the battery, and that's why the bulb is glowing. So in the first picture, if you see, this is an incomplete circuit. So incomplete circuits are in which electric current cannot flow, and complete circuit is in which electric current can flow and the bulb lit up. So this is the definition of incomplete and complete. Let's move on. Electric symbols. So now electric symbol is used to identify the circuit, or as you can see, we use these symbols to draw diagrams of circuit, and they are also used for identifying. So you see in the first picture there is a battery sign. Battery sign is like one line which is big and one line is short, and you can also put a plus and a minus sign in it also. It's your choice. Then you see the wire. Wire is really simple sign. Wire only has a line. You need to make a wire. Then you see the bulb. Bulb is a circle and inside there's a cross in it. And then if you see the buzzer is like you make the upper side would be like a bow, and then the down side you're going to make like a cylinder. Okay, so this is a buzzer. So if you don't understand the buzzer, they have shown you in the picture the real buzzer, that how is the buzzer looks. Then you move on down, then there's a on switch. So on switch is like a straight line which you make and two dots between them. Okay, this is like a on switch, or you can say close switch. And if you see in the other side, that is a off switch or a open switch, which has like a line, then line goes up, and then like two dots, and then line goes to the right side. So this is like a simple diagram of simple symbol, you can say, of on switch and off switch. Now if you see the motor is like a simple sign like a bulb. So it has like a circle, and inside it has a M written in it. So this is a sign of motor. And if you see the motor in this is a real picture of motor. As you can see, they have shown you how the motor looks. Let's move on now. Drawing circuit symbols. So this is really easy. In the paper you all get that draw the circuit symbols. They have given you a circuit and they say that draw the symbols of it. So as we have done at the previous slide, we have seen the symbols. So now you see you need to make the symbols. You need to learn these symbols and then you would be able to do them. So the bulb, as I told, a circle, and inside there would be a cross, and the battery would be shown. There's two batteries, so we are going to make two times one big line, two times big lines, and two times small lines. Okay, this would be the whole symbol circuit. This would be simple circuit. Let's move on. Switches. So switches are used to open and close the circuit. Okay, this is a definition of switches. So see the first picture. When a switch is open or off, there is a gap in the circuit. When a switch is open or off, there is a gap in a circuit. An electric current cannot travel around the circuit. Okay, if you see this picture, you see the switch is open or off, so this means that the electricity cannot travel to. But you see in the second picture, the switch is closed and the electricity can pass through it. When a switch is closed or on, it makes the circuit complete. Electricity can travel around the circuits. Okay, so you see the definition of switches would be: switches allow switches open and close the circuit. This would be the definition of switches. Let's move on. Changing number of batteries and cells. So changing number of batteries and cells are the same. That means that how many you want to put in a circuit, how many battery you want to put, 5, 4, 3, 1 or 2. Adding more batteries to a simple circuit will increase the electric energy, which will make a bulb brighter. Or if you will add more than 2 batteries, if there's a 1 bulb and you're adding 4 or 5 batteries, so what will happen? The bulb will be blast, because if it is getting more and more flow, so it will blast. So try to put, if you have 1 bulb, you need to put 2 batteries or 1 battery. Okay, let's move on. Changing number of bulbs. So now it's your choice how many bulbs you want to add in your circuit. You want to add 2 or 1. So if you have 1 battery and you're adding 2 bulbs, so the brightness of the bulb would be dimmer. If you will add 2 batteries and 2 bulbs, the brighter would be medium. They would get medium. If 3, then they would be brighter. So you see, adding more bulbs to a simple circuit will make the bulbs dimmer. Okay, it makes the bulb dimmer, as I have explained you. Let's move on. Changing the length of the wire. So if you change the length of the wire, you do the wire longer, so the electric current will take time to flow and go to the bulb, and bulb would be dimmer, and even it would take time, and then it will not glow suddenly. It will go after like 1 second or 2 or 3 seconds it would take, and then the bulb would glow. The bulb would be dimmer if you're going to do the wire long. So see, lengthening the wires in a simple circuit will make the bulb dimmer. And the second is, long the wire, the more the resistance, so less electric current can flow and the bulb dimmer. Means the less electric current can flow and the bulb would be dimmer. As I told you that the less current would flow and the bulb would be dimmer. But if you do the wire shorter, the bulb would be brighter and electric current would be more. Let's move on. Changing thickness of wire. So if you change the thickness of wire, if you do thick wire, if you put thick wire in your circuit, the more current will flow to it. If you will put thin wire, the less current would flow to it and the bulb would be dimmer. There's a difference between them. So see, thicker the wire in a simple circuit will make the bulb brighter, as I told you. See the second one. Thicker the wire, less resistance, so more electric current can flow. Okay, so if you will take the thinner wire, the more resistance and less electric current would flow. Okay, so people prefer to go for thicker wires. Let's move on. Electric conductors. So electric conductors are like copper. If you talk about the copper, copper is a really good insulator. Insulators are which let the electric current pass through. Okay, so you see the plastic or rubber to insulate the electric current. Oh, sorry, I forgot to tell you. Current is which let the electric current flow through, and insulator which do not let electric current flow through. Sorry, this was a mistake. Current let the electricity pass through, but insulator not. So see, all metals can conduct electricity, but not all are good electric conductors. One of the best electric conductor is the copper. That's why it's commonly used for making wires. Yeah, if you see in your rooms or your houses, the copper is used because this is the best conductor. Okay, so the plastic and rubber are insulators. They do not let electric current pass through them. Okay, let's move on. Electric current insulators. So most of non-metal can conduct electricity, but one of the non-metal that can conduct electricity is pencil lead or carbon. So see in this picture, you see that the inside from which you write from the pencil. So what happens is that the inside of the pencil is a conductor and the outside is the wood. So wood is an insulator, so it do not let the light pass through. So if you do the nip a bit, the inside ones towards the pins, so the bulb will glow. But if you are going to do the wood, attach the wood with the pins, the bulb would not light up because the wood is insulators. Let's move on. Insulators. So insulators are that do not let the light pass through it. The insulators are the outside cover of the wire, and inside is conductor which let the light pass through. Copper is a conductor, so that lets the light pass through it. And then this hole is made of this. Then this is made of wire. So the right side, if you see, there's a plus sign, and the left side there's a minus sign always. Okay. If there's no electric insulator, you will get electric shocks when you touch it. Yes, as you can see in these two pictures, if you touch them, you would get a severe electric shock in that, and then you can die or you can be safe. Okay, so that's why there's insulator added on the top of the wire.